So when you're doing trig, there is a set of three angles that are considered to be special. 30 degrees, 60 degrees, and 45 degrees. The reason these three angles are said to be special is because it's so easy to find their ratios without using a calculator. So let's start with 30 degrees. If I draw a triangle like this, and this is 30 degrees, and this here is 60 degrees. What is the sine of this 30, the sine of this 60, the cosine of this 30, the cosine of this 60, the tangent of the 30, and the tangent of the 60? We can figure that out by drawing an equilateral triangle. Let me just sketch this again. Yeah, by drawing an equilateral triangle. So 2, 2, 2. Just size 2, 2, 2. And I can cut it in half like that, so that this is 2. And now that it's cut in half, this distance here is going to be 1. This will be a 90 degrees. And this missing piece will be square root of 3 from Pythagoras theorem. Since 1 squared plus root 3 squared equals 2 squared. So this was 60 degrees when it was in the equilateral triangle. Now it's 30 degrees. And this here is now 60 degrees. So what's the sine of 60? It's the opposite, which is 1. The sine of 30 degrees is the opposite, which was 1, with the hypotenuse, which is 2. Then the cosine of 30 degrees will be the adjacent, which is square root of 3, over the hypotenuse, which is 2. Then the tangent of 30 degrees will be that opposite, which is 1, over the adjacent, square root of 3. Then when we look at 60 degrees, the opposite, the sine of 60 degrees will be the opposite over the hypotenuse, giving us square root of 3 over 2. The cosine of 60 degrees will be 1 over 2. And then the tangent of 60 degrees will be the opposite over the adjacent, which is square root of 3 over 1, which is just square root of 3. And that's how we find the sine, cosine, tangents of 30 degrees and 60 degrees. Then now let's go to 45 degrees. For 45 degrees, you can draw a simple isosceles triangle. A simple isosceles triangle like this. Length 1, 1. And this will be the square root of 2 from Pythagoras theorem, since 1 squared plus 1 squared equals root 2 squared. This here will be 45 degrees. This will also be 45 degrees. This will be 90 degrees. So what's the sine of 45 degrees opposite over hypotenuse, giving us sine 45 degrees as 1 over root 2. Cos 45 degrees is going to be the opposite, the adjacent over the hypotenuse, which is still 1 over root 2. Then what about the tangent of 45? It's going to be the opposite over the adjacent, which is 1 over 1, or simply 1. And that's how you find the trig ratios of the special angles. To summarize, we have three special angles: 30 degrees, 45 degrees, and 60 degrees. The sine of 30 is 1 over 2. The sine of 45 is 1 over the square root of 2. The sine of 60 is square root of 3 over 2. The cosine of 30 is root 3 over 2. The cosine of 45 is 1 over root 2. The cosine of 60 is 1 over 2. Then moving on to tangent. Tangent of 30 is 1 over root 3. The tangent of 45 is 1. And the tangent of 60 is root 3. Yeah. And there you have it. That's your values for the special angles.